Hey, all you cool cats and kittens. Sorry, I couldn't help myself. So it took a couple of days, but now that Edpuzzle's working, we've reviewed solving systems of equations by graphing. So it's time to use an algebraic method here, like the substitution method. So let's remind ourselves here that the substitution method for solving systems of equations requires us to substitute, is that how you spell that? Or replace one variable in an equation with an equivalent expression. So if we need a little bit of reminder of what that means, I heard another teacher give this example, and so I thought I'd share it with you. If you're familiar with Indiana Jones and the Raiders of the Lost Ark, or even if you're not familiar, in this scene, Indiana Jones is trying to replace this golden idol with a bag of sand. And it's really important here that the weight of these items, the bag of sand, has to have the exact same weight as the golden idol in order for this to work. And so that's kind of what we're thinking about here, is it has to be a perfect equivalent, a perfect substitute. I won't spoil the movie for you. But we're looking for a perfectly equivalent expression. And so if we do that, then the goal is to be able to solve for one variable at a time. We've had lots of practice solving equations in one variable, and so substitution method allows us to use that skill. So we're going to solve this system of equations, y equals 3x plus 5 and y equals negative x minus 3. So notice that these both have a y in them, right? And a y is a y. The y will be the same y anywhere else. And it just so happens that y is equal to 3x plus 5. That equal sign means that these values have the exact same value. So what we can do is we can take this 3x plus 5 and use it to replace the other y value, just like Indiana Jones. And so what we end up with is the expression or the equation 3x plus 5 is equal to negative x minus 3. They are perfectly equivalent, so we can replace one with the other. From here, there's a number of ways we could solve this. I'm going to start by adding x on both sides. It's the opposite of subtracting x. And so I'll get 4x plus 5 is equal to negative 3, since those x's cancel out. And then I'm going to subtract 5 from both sides. I'm going to get 4x is equal to negative 8. And then one more step to completely isolate x is to divide both sides by 4. And I get x is equal to negative 2. So I've solved for x, right? I was solving for one variable at a time, and now I need to know my y value, because remember from our graphs that our solution has to be an x and a y pair. A coordinate point is x and y. So I need a y value. Luckily, I have a couple of options. I know that y is equal to 3x plus 5. I used that information a minute ago. So I'm going to take the x value that I just found, this negative 2, and I'm going to substitute it or replace directly with the x in that equation. And so I'll have the statement that y is equal to 3 times negative 2 plus 5. From here, I just need to evaluate. 3 times negative 2 is negative 6, and negative 6 plus 5 is equal to negative 1. So it looks like I've got a solution, negative 2, negative 1. But I could always check this, right? Checking is a good habit. And to check this, I'm going to use that other equation that I didn't use the first time around, and I'm going to verify that these two x values, negative 2 and negative 1, excuse me, these two values, and one x value and one y value, both work out. So I'm going to replace y with negative 1. I'm going to replace x with negative 2. Negative 2, that would be positive 2. And 2 minus 3 is in fact equal to negative 1. So it looks like this works out, and my solution, negative 2, negative 1, is exactly what I want. So just a couple of pieces of advice here before we do some more practice problems. Remember, we can substitute for either variable here. In this example, we happened to substitute for the y value because it was the one that made the most sense, right? It was kind of the easiest option here, and that's okay. That's totally valid. And then, like I just mentioned, our answer should always be in the form of a coordinate point. That's x and a y. So one solution, two numbers. So let's practice with another system of equations. This time at the bottom of the page, I've got 2x plus 2y is equal to negative 28, and y equals 2x plus 13. So this one's a little bit different because that first equation doesn't look like y equals, it has a y in it, but my second equation says that y is equal to 2x plus 13. And the fact that I've got that y all by itself makes it really easy to substitute in that first equation. I can just directly substitute it. Now, something to be careful of is to remember that I'm only substituting the y. I'm not substituting the 2 and 2y. So when I write this out, I'll have 2x plus 2 times 2x plus 13 is equal to negative 28 because I'm only replacing the y value with that 2x plus 13. That 2 out in front of that expression, 2y, has to stay there. But I've got one variable. I have two x's, but it's the same variable. If at this point I happened to have an x and a y, that would be a really good opportunity to go back and check my work. But I've only got x's, so I'm ready to go. I'm going to use the distributive property to get 2x plus 4x plus 26 is equal to negative 28, right? Distributing that 2 to 2x and to 13. 2x and 4x simplify to make 6x. 6x plus 26 is equal to negative 28. And I want to start to get x all by itself, so I'm going to subtract 26 from both sides. I'll get 6x is equal to, let's see, that would be 54, negative 54. And if I divide both sides by 6, I'm going to get x is equal to negative 9, because 6 times negative 9 would give me negative 54. Now, I could use either equation to back substitute to find my y value, but the second equation is already set equal to y. I'm allowed to choose the one that's going to be easier for me. There's no reason to make something more difficult than it has to be. So again, I'm just going to replace that x directly with the value that I found. So 2 times negative 9 plus 13. A little distributive property, 2 times negative 9 will be negative 18 plus 13. Negative 18 plus 13 is negative 5. So it looks like I've got the coordinate point negative 9, negative 5. But again, I just want to check because checking is an excellent habit. And so I'm going to use the equation that I haven't used yet. I'm going to do the 2x plus 2y is equal to negative 28. And so I'm checking, when x is negative 9 and y is negative 5, does that hold up? So 2 times negative 9 plus 2 times negative 5, I wonder, does that truly equal negative 28? 2 times negative 9 is negative 18. 2 times negative 5 is negative 10. And negative 18, take away 10 more, right? So go further into the negatives, does give me negative 28. So my solution here is negative 9, negative 5. And if I had checked it and it hadn't worked out, you guys know that doesn't mean that I don't know what I'm doing. It means I made a mistake, right? And mistakes are going to happen here, especially with the number of steps that this took. It took 1, 2, 3, 4, 5, 6, 7, 8, at least 9 steps after we substituted. So a mistake is very likely, very possible, and it is also not the end of the world. So I want to do one more example together, and I want to do this example because the starting strategy isn't super obvious. So we've got y minus 2x equals 3, and 3x minus 2y equals 15. And one of the tricky things about this is that I don't have anything that looks like just y equals or x equals for me to just, pick up something and substitute it. My x's and y's are pretty mixed into my equations. But I can really easily manipulate this just a little bit to make this process smoother for myself. So if I think about y minus 2x equals 3, well, I can get y all by itself with one step. If I just add 2x to both sides, now I've isolated y, and I know that y is equal to 2x plus 3. That is something that I can now say, well, if y is equal to 2x plus 3 here, it must also equal 2x plus 3 in the other equation. I could have also isolated an x value and gotten a statement that said x equals. Again, I'm allowed to choose the thing that's going to be just a little bit easier, and that's what I did here. So I'm going to replace, I've got 3x minus 2 times 2x plus 3. I'm going to do that substitution is equal to 15. Now I'm going to do some distribution here, so that'll be minus 4x minus 6 is equal to 15. 3x minus 4x is going to be negative 1x. And to start to isolate that x, I'm going to add 6 to both sides and get negative 1x is equal to 21. 15 plus 6 is 21. And now I want to isolate x completely, so I'm going to divide both sides by negative 1. And I get x is equal to negative 21. And so now that I know what my x value is, I'm going to pick up that x value and I'm going to substitute it in kind of this secondary little equation that I used or that I created. So 2 times negative 21 plus 3. So 2 times negative 21, I believe that's negative 42, plus 3 would give us a y value of negative 38. So according to all my work here, my solution will be negative 21, negative 38. Now, if we don't recognize the importance of checking by now, we need to rewind and rewatch the video because mistakes will happen, especially the fact that my equation, y equals 2x plus 3, was something that I kind of manipulated and created originally. So again, it's not going to hurt me to check. It'll take an extra 30 seconds, but it's certainly not the end of the world here. So I'm going to use the other equation, and I'm going to double check what happens when I put in negative 21 and negative 38. And I'll probably need to grab my calculator for this. It's been a while for me too. 3 times negative 21, that's negative 63. And then 2 times negative 38, or negative 2 times negative 38, will be a positive 76. And we're looking for, does that equal to 15? So 76 minus 63 actually equals 13. So this is a really great opportunity. I expected to do this right, but I think I made a mistake. So I'm going to go back and I'm going to just check my work here. So let's see, when I move this around, I had 2x plus 3. I think that's okay. I substituted negative 6, c plus 15, that is 21. Let's see, over here, what did I do? Oh, I wonder if this is it. Negative 42 plus 3 is actually equal to negative 39. That's it. So It's not that I didn't know what I was doing. I made a silly adding mistake at the very last step. That's not negative 38, that's negative 39. So I bet when I go back and check, so 2 times negative 39 instead of negative 38, this will be positive 78, and this will be 15, and that's what I want. So my solution here, now that I've double checked and revised, is negative 21, negative 30, oops, I almost wrote it again, negative 39. Okay, so is it important to go back and check your answer? Yes. Is it the end of the world if you make a mistake? Absolutely not. That's how you know it's me making this video, right? So I've got a few for you to try. I've got about 8 here. If you're not really in a place or a time where you feel like you can do 8 of these, I encourage you to choose 4. Maybe do 4 out of the 8 and try them out and check your answer on OneNote there or using Desmos. And if you have any questions, please either write them out on your OneNote, like here's my question, Miss Wombold, or you can check out Zoom, or you can email me or message me on Canvas. You guys have lots of options here. So thank you for staying engaged. Thank you for checking in. I miss all of you, and I look forward to hearing from you soon.